Hello everyone, so I just made a video for my channel in Spanish. I have a channel that's entirely in Spanish, and I thought, you know what, let me just go ahead and make the same video now for this channel here in English, just in case anyone wants to learn a little bit of mathematics. So what we're going to do in this video is I'm going to show you a book, and I'm also really just going to focus on some math. We're actually going to do a math problem, and I picked a problem that is a little bit hard. So if you watch this video and you feel like you can actually do the problem before me, that's really good because I think that this is a hard problem. If you're in a Calc 1 class, this is considered a tough problem, and I think most people would not be able to do it simply because most people have not maybe been exposed to this type of problem. But it's a really cool problem because if you understand calculus, you might be able to figure it out. So let me show you what the problem is, and then we'll write some stuff down, and then we'll go through the solution super carefully. Oh, and this book is really cool. I'll show you the book in a minute. So determine the constant c such that the straight line joining the points 0, 3 and 5, -2 is tangent to the curve y equals c over x plus 1. So what that basically means is that this line is going to have the same slope as this curve. So that means that the slope of the line has to be equal to the slope of the curve. So let's go ahead and write all that down and go through it carefully. So we've got a line. Let me zoom back out here so we can get a good look. So our line, it's a line connecting 2 points. So the first point was 0, 3, and the other point was 5, -2. And then our curve, so this line has to be tangent to this curve here, y equals c over x plus 1. So what that means is that the slope of this line is equal to the slope of this curve. The slope in calculus is the derivative. So a good first step will be to find the slope of this line and set it equal to the derivative of this function. By the way, this book is awesome. I'll leave a link in the description. This is an older edition, okay, of Thomas Calculus, and this actually has answers to every single problem. So if you buy the newer edition, I'm pretty sure the newer edition doesn't. I have several editions of this book. I have, I think, the 13th edition, and I think that just has answers to the odds. But this has answers to all of the problems, which is completely ridiculous. I'll try to leave a link in the description, and it's just awesome. It's awesome because it has all the answers. So you can go through and you can practice interesting problems like this, and then you can check your answers, which is really cool. All right, so let's find the slope of this line, and I'll label stuff, why not? So we're going to call this x1, we're going to call this y1, this is x2, and this is y2. And you probably know the formula for the slope. You've probably learned it somewhere. It's m equals, and it's the change in y over the change in x. So we can do y2 minus y1, or rather y sub 2 minus y sub 1, over x sub 2 minus x sub 1. So this is equal to -2 minus 3, so -2 minus 3 over, and then 5 minus 0. So we get -5 over 5, so we get -1. So the slope of this line is equal to -1. Okay, good stuff. And that slope is constant. That's the really cool thing about lines, right? The slope is always going to be the same. Whereas this function, the slope is going to change. The slope is called the derivative. So you can think of the derivative as a slope function. That's really one of the key ideas in calculus. To find the derivative here, there's a really cool trick. So whenever you have a fraction and you have a constant up top, all you have to do is you can take the bottom piece and bring it up. So all of this is really to the first power. So when we bring it upstairs, this becomes y equals c parentheses x plus 1 to the -1, right? It's pretty cool. So now we can take the derivative and use the chain rule. So we have something to a power. The c is a constant, so it hangs out. So y prime is equal to, so we bring down the -1, so we get -c parentheses x plus 1 to the -2, because you subtract 1 from the exponent always, and times the derivative of the inside function. The derivative of x is 1, the derivative of 1 is 0. All right, so this is y prime equals, we can bring this back downstairs, -c over x plus 1 squared. All right, so now we know that this is the slope of the function. So we want this to be equal to -1. So let's take this and set it equal to -1. So you have -c over x plus 1 squared. I'm sorry, I have to smell this book. It just smells so good. It's just, oh, it's intoxicating. This particular copy smells incredible. And that's why I'm using this book now to do this video. It just smells so good. So this is equal to -1. To solve this for c, I'm going to just skip some steps here. So we're going to multiply by x plus 1 squared and also by -1 at the same time. That's going to give us c equals x plus 1 squared. So we're kind of stuck, right? We have to find the value of c. And so now we really have to think, so what happens when you have a curve that's tangent to a line, right? It means it just touches at just one point. So right there, that's where it touches, right there. So we know that means that the slopes are the same, but it also means they share a point. In particular, they share an x value. So once we find the x value that they share, we can plug it back in here and find the value of c. To do that, what we're going to do is actually find the equation of the line. So the line has this slope. Let's use y equals mx plus b. And now what we can do is plug in the slope. So y equals negative x plus b. And now you can pick any point you like. You can use this one or this one. I think this one's an easier choice because it's 0. So let's use this one. So and you can use either or. You should check. If you use this one, you'll get the same answer for b. So y is 3, and then x is 0. So negative 0 is just 0 plus b. So b is 3. So let's take this value of b and plug it back in here for y. For b, to get y, or here rather, sorry, whoops, let's plug it in here. Blah. This is negative x plus 3, there we go, good stuff. There's our line. We want it to be equal to our function, which is up here. And we know it's c, so now let's plug in c. So we have negative x plus 3 equals, c is x plus 1 squared, going a little bit fast, it's a long problem. And then you lose a copy of x plus 1 because it cancels. And now we can solve for x, and be really careful here. It's really easy to get like carried away and go super fast. So plus x, minus 1, boom, boom. So we get 2 equals 2x. Divide by 2, so we get x equals 1. Now that we have x, we can plug it back in here and find c. And I'm going to go over the whole thing one more time at the end, and then we'll take a quick look at the book. So 1 plus 1 squared, and that's equal to 2 squared, which is equal to 4. So c is equal to 4. So that's the answer. So let's go over it one more time, and then we're going to check the answer in the back of the book, which is one of the best things about this book is that you can check your answers. It makes it awesome. So again, the original question wanted us to find c such that the line connecting these 2 points is tangent to this curve. What does that mean? That basically means this. It means the line just touches at a single point. When that occurs, 2 things actually happen. 1, they share a point. 2, their slopes are the same. We started by finding the slope. The slope of a line was found using our basic formula. The slope of this function was found using calculus, right? So we took the derivative and we set it equal to the slope of a line. That was here, and we ended up with this. Then we got stuck. We say, hey, wait a minute, what's x? Well, that's when you have to realize, wait a minute, they also share a point, not just a slope. So then what you do is you try to find the x value of that point. So what you do is you set the y values equal. You set your line equation, which we found by using y equals mx plus b, to your function equation, right? And then when you set them equal, you can solve for x. Once you get x, you plug it back in here, boom, there's the value of c. Very standard problem, by the way. Problems like this also show up in modern books. I'm thinking of like Calculus by Larson and Calculus by Stewart. Those are also excellent calculus books. And there are problems in those books that are very similar to this that follow the same style. So once you do one of those problems, even if you don't have to necessarily memorize the problem, but once you understand what it means for 2 functions to be tangent and what that implies, when you see new problems like this, you can tackle them. So I'm curious, were you able to solve this problem before me? Did you think it was easy? Did you think it was hard? Leave a comment below. I'm curious how many people were able to solve it. In a typical calculus classroom in college, most people, I would say, would not be able to solve a problem like this. And it's not because people are, again, it's not because people are dumb or anything. It's just because they haven't been exposed to it, because in a typical classroom, a lot of times there's no time to do problems like this. I usually do a problem like this whenever I teach calculus. So this is number 36 in the miscellaneous problems in section 3.9. So look at this. Look at all these answers in the back of the book. It's awesome. It calls them articles. Article 3.3. It's very like fancy, very, very fancy. Old school. It smells so good. Just gotta, incredible. So there it is. Let's check the answer so you can see that is indeed correct. So C is equal to 4. That's the answer there. So wonderful book on calculus. Great for self-study. This particular copy is great for self-study. This is the 4th edition of Thomas Calculus. I think I've reviewed this book before, but I'm not sure if I've talked about this particular edition. I own several versions of this book, several editions, And also there's some other books by Thomas that, you know, they have different names and they were written, oh, before. What's this? We found something in the book. What's this? What's this? This is a hidden treasure. Wow, it's someone's name and address. Okay, so let me, 1973. Wow, okay. Huh. Postage 6 cents. A stamp was 6 cents back then. Really incredible. Casual clothes. Really weird. Anchor committee meeting. Yeah, this is probably, I mean, 1973. That's a long time ago, right? So, and this looks like the wrapping for a pack of cigarettes. How weird, right? Yeah. And I've done several problems from this book, and I've never seen this. I'm just going to leave it in there because I feel like it's part of the book, right? I don't want to disturb that. So yeah, hopefully you've enjoyed this video, and if you're still watching this video and you are not a subscriber to this channel, consider subscribing. I post all kinds of stuff. I usually post like book reviews and learning content for all subjects, not just math. Sometimes I post math problems. It just depends. I also have a channel in Spanish. You can check that out. It's called Math Sorcerer Español. I also have an Instagram. If you have Instagram, check out my Instagram. It's at The Real Math Sorcerer. I also have a Patreon, so check out my Patreon. That's just The Math Sorcerer. You can Google it, it'll come up, or you can just check the link in the description for my Patreon. Hopefully you've enjoyed this video, and hopefully you've learned some math. Until next time, good luck, take care, and keep doing math.